Hello everyone, I'm Saptarshi and welcome to the Tech Think Tank. Today we are going to dive into the world of microservice.
With technology evolving every day, it's essential to stay up to date and informed. That's where we come in.
Our mission is to bring you the latest and greatest in technology and help you understand how it can impact your daily life. So sit back, grab a cup of coffee, and let's get started.
Oh no! The internet is down. Let's utilize the time by discussing microservices. A microservice is a small, independently deployable component of a larger software application. In a microservices architecture, an application is broken down into a collection of these small, loosely coupled services, each of which is responsible for a specific aspect of the overall application. Microservices are designed to be loosely coupled, meaning that each service communicates with other services through APIs, and changes to one service do not affect the others. This makes it possible to develop, deploy, and manage each service independently, allowing for greater scalability, resilience, and flexibility. Microservices are typically developed using agile methodologies and are deployed using containers, such as Docker, which provide an isolated environment for each service to run in. This makes it possible to deploy and run each service on different servers, or even in different locations, providing further scalability and resilience.
A microservice framework is a set of tools and libraries that help developers to build, deploy, and manage microservices applications. The main goal of a microservice framework is to make the development and deployment of microservices easier and more efficient by providing a standardized way of building and deploying individual services.
Some key components of a microservice framework include 1. Service discovery, the ability to discover and communicate with other services in the system, usually through a registry. 2. Load balancing, the ability to distribute incoming requests across multiple instances of a service to ensure high availability and scalability. 3. API gateway, a component that acts as an intermediary between the client and the microservices, handling tasks such as request routing, composition, and security. 4. Configuration management, the ability to manage and maintain configuration information for each microservice, such as environment-specific settings and secrets. 5. Monitoring and logging, the ability to monitor the health and performance of microservices, and collect and store log data for troubleshooting and analysis. 6. Deployment and scaling, the ability to deploy and manage the lifecycle of microservices, including scaling and rolling updates.
A microservice framework can provide many benefits, including 1. Scalability. Microservices can be deployed, scaled, and updated independently, allowing for greater flexibility and scalability compared to a monolithic architecture. 2. Resilience. Since each microservice is self-contained, failures in one service do not affect the entire system. This makes microservices-based applications more resilient and reliable. 3. Modularity. By breaking down a complex application into smaller, more manageable components, it becomes easier to modify, maintain, and update the application. 4. Technology diversity. Microservices can be implemented in different programming languages and technologies, allowing developers to choose the best tools for each individual service.
There are many different microservice frameworks available, both open source and commercial. Some popular open source options include Isho, Kong, and Linkerd, while popular commercial options include Amazon Web Services, AWS, AtMesh and Google Cloud Service Mesh.
Some popular microservice frameworks include 1. Spring Cloud, an open-source framework that provides tools and libraries for building microservices-based applications on the Spring platform.
2. Microprofile, an open-source platform that provides a microservices-based programming model for Java applications. 3. Node-RED, an open-source visual tool that makes it easy to wire together microservices using a graphical interface.
4. Amazon Web Services. AWS provides a variety of cloud-based tools and services that make it easy to build, deploy, and manage microservices-based applications. 5. Kubernetes, an open-source platform for automating the deployment, scaling, and management of containerized applications.
The choice of microservice framework will depend on various factors such as the specific requirements of the application, the technology stack being used, and the experience and preferences of the development team. It's important to note that a microservice framework is just one aspect of building a microservices-based application. There are many other components and technologies that need to be considered, such as service discovery, service registry, API management, and security.
Now let us discuss the difference between a microservice architecture and a monolithic architecture. Microservice and monolithic architecture are two different approaches to building software applications. In a monolithic architecture, an application is built as a single, tightly coupled unit where all components are packaged and deployed together. This approach is simple to develop and deploy, as all components are part of the same code base.
However, as the application grows in size and complexity, it can become difficult to maintain and scale. If a problem occurs in one component, it can affect the entire system, and if a change is made to one component, it often requires the entire system to be redeployed.
On the other hand, in a microservice architecture, an application is broken down into smaller, independent services, each of which is responsible for a specific aspect of the overall application. These services communicate with each other through APIs, and can be developed and deployed independently, allowing for greater scalability, resilience, and flexibility.
If a problem occurs in one service, it only affects that service and not the entire system, and changes can be made to individual services without affecting the entire system. In summary, the main difference between microservices and monolithic architecture is that microservices offer more flexibility, scalability, and resilience, but are more complex to develop and manage, while monolithic architecture is simpler to develop and deploy, but can become difficult to maintain and scale as the application grows.
Thanks for joining us today at the Tech Think Tank. I hope you learned something new and valuable about microservice. If you enjoyed this video, don't forget to like, comment, and subscribe for more informative content. Until next time, this is Saptarshi signing off. Stay curious and keep exploring the world of technology.